In the first part of our lesson today, we're going to talk about percent change. All right, a percent change is either going to be a percent increase or a percent decrease, depending upon how the quantity itself changes. A percent of change describes how much a quantity has changed, expressed as a percent of the original quantity. Okay, the percent change is always a percent of the original quantity. That's going to be very important later on when we're talking about the percent change equation. When the quantity increases, the percent change is called a percent increase. And when the quantity decreases, the percent change is called a percent decrease. In our first example, we have a pet frog, and it measures 51 millimeters in body length while it's sitting. And we can see that here at the beginning of the picture. It's sitting. The body length is 51 millimeters. Its body length extends to 89 millimeters while jumping. At the end of the picture here, while it's jumping, we can see the body length has extended to 89 millimeters. We need to find the percent increase in body length from the frog from sitting to jumping. And at the end, we're going to round our answer to the nearest percent. So taking a look at our equation down here, all right, notice that this is a little different than the equation that we've been using, which said part equals percent times whole. Okay, part equals percent times whole is the basic percent equation. Starting today and in the next few lessons, we're going to give specific equations for the types of problems that we're working with. When we're dealing with a percent change, the equation changes to this right here. It becomes change equals percent times original. The rate, though, still has to be expressed in decimal form. So this percentage here, in order to use this equation, we would have to change it into a decimal first. So there are a few steps that we need to follow when we're finding a percent change. The first thing that we need to do, step number one, is calculate the amount of change. Calculate the amount of change. As you can see in the equation, we need to know the amount of change because the amount of change is a percentage of the original amount. So let's calculate the amount of change in the body length. It started here at 51 millimeters. It ends at 89 millimeters. If we do 89 minus 51, that's going to equal 38. Okay, so the amount of change is 38 millimeters. Okay, now step number two, we're going to set up the percent change equation. In the box, we see that it says change equals percent times original. The amount of change we just calculated right here to be 38 millimeters. So 38 goes in for the amount of change equals the original body length we knew at the beginning when it was sitting, it was 51 millimeters. And if we reread the question, it says to find the percent. So we are looking for the percent in this example. We'll use the variable r for the rate. 38 equals r times 51. All right. Now that we've set up the percent change equation, step three, we are now going to calculate the percent change. In order to get r all by itself, right now r is on the right-hand side of the equal sign, but it's not alone. It's being multiplied by 51. To get r all alone, we'll have to divide by 51. And if we do that on the right, we need to do the same thing on the left. On the right, 51 divided by itself is 1, leaving us with r. On the left, you're going to punch into your calculator 38 divided by 51. You're going to get a long decimal. You need to write out all of those numbers from your calculator. 0 decimal, 745098039. Okay? This is the decimal form of our answer, but the question said what was the percent change? So we're going to take this decimal and we're going to convert it into a percent. Remember, all you do is take this decimal and move it 2 places to the right. So our decimal point would end up here, meaning that the percentage is going to be 74.5098039%. If we reread the question one more time, it says at the end to round your answer to the nearest percent. So if we take a look at this number right here, this is going to be approximately, well, it looks like 74%. We check the tenths place, we have a 5, which is enough to round us up to about 75%. Okay, so we can say the frog's body length increased by about, because we rounded, by about 75%. Okay, so I know my percentage and I've labeled it as an increase because, again, it started at 51, it went up to 89, so that's an increase in body length, so we had a percent increase in this example. In our second example, we're told that Patty got a score of 80 on her first math test. On her second math test, she received a score of 96. What is the percent increase? Percent increase from test 1 to test 2. Again, it's a percent increase because her score went up from the first test of 80 to the second test of 96. Our process, though, is going to be the same. The first thing we need to do is calculate how much change there was. Okay, well, to figure that out, we're just going to subtract the two scores, 96 minus 80. Her score changed by 16 points. Her score changed by 16 points. Okay, next thing we're going to do is set up the percent change equation. Remember, it says that change, the amount of change, equals a percentage of the original amount. We just calculated the amount of change right here to be 16 points. So 16 goes in for the amount of change. It says, what is the percent increase? So once again, we're looking for R, the rate, the percentage. And now we need Patty's original score. She got a score of 80 on the first test. The first test is the original, so we'll put 80 as the original. Now let's calculate the value of R. R is on the right-hand side, but it's being multiplied by 80. So we're going to have to divide by 80 on both sides to get the value of R. On the right, 80 divided by itself is 1, leaving us with R. Punch in 16 divided by 80 into your calculator, and that's going to give you a decimal of 2/10. But again, we need to take this decimal and convert it into a percentage. 2/10 is equal, move the decimal place once, twice, that's going to be 20%. So we can say Patty had a 20% increase in test score. In test scores, okay? Now to follow that up, question 3 says, Tim got a score of 96 on his first math test. He didn't bother to study and he received an 80 on the next math test. What is the percent decrease from test 1 to test 2? Notice this time our original score was 96. The next score was 80. Since that went down, we're finding a percent decrease, but the process is still the same. Number 1, we're going to figure out how much change there was. In order to do that, again, just subtract the two test scores, 96 and 80. 96 minus 80 equals 16. So there was a 16-point change. Then we're going to set up the percent equation, which again says that change equals a percentage of the original score. Now we're going to go ahead and calculate. We're going to first plug in our values. The amount of change was 16 points. It says, what is the percent? So R is what we're looking for. And the original score for Tim got a 96 on the first test. So we're going to use 96 as the original score. Okay, so let's figure out what R is. R is on the right side of the equal sign. It's being multiplied by 96. So we're going to have to go ahead and divide by 96 on both sides. When we do this on the right, 96 divided by itself is 1, leaving us with R. Use your calculator, punch in 16 divided by 96. And notice what happens, okay? This time we get a repeated decimal, okay? But not all the digits repeat, only that 6 repeats in the hundredths place. So we're gonna have 16 hundredths, but we're gonna put a bar only over the 6 because the 6 is the only number that repeats. Now we're gonna convert this into a percentage. 0 and 16 hundredths with the 6 repeating. Okay, well, remember, that means that there's a whole bunch of 6s after that. You take this decimal point and you move it once, twice to the right. So now we're going to have 16 decimal, and now notice that, again, there's still a bunch of 6s here, so 6/10 repeated as a percentage, and this is better known as 16 2/3%. Okay, so we can say here that Tim had a 16 2/3% decrease in test scores. Now, in example 4, it says that the test scores were the same values in questions 2 and 3, and the amount of changes in the test scores were the same. Explain why the percent change for each question was different. Okay, notice that if we go back up, Patty had an 80 and a 96. Tim also had an 80 and a 96. Okay, so they had the same test scores, which means their changes were different. Patty had a 16-point change. Tim had a 16-point change. So their amount of changes were the same, but the percent changes were different, all right? Patty had a 20% increase. Tim had a 16 2/3% decrease. If the test scores were the same and the amounts of change were the same, why did these percents come out to be different? Well, the reason why they're different is because the percent change is based off of the original score. Patty's original score was an 80, while Tim's original score was a 96. Because the original scores were different, that means the percent changes are going to be different, okay? The percent changes are different. The percent changes are different because the original scores are different. Okay, percent change is always based on the original score. All right, a common mistake is to think, oh, the numbers were the same. All right, so that means the percent changes are going to be the same. But no, you have to look and see what the original values were. Okay, if the original values are different, then your percent changes are going to be different. All right, let's talk about the retail world. So when you go shopping, the retail world calls a percent increase a markup. Okay, when the price goes up, they call that a markup. The retail world calls a percent decrease a discount. So when things are on sale, they discount the price. In example number 5, it says that a ski jacket was originally priced $95. It is discounted by $28.50. What is the rate of discount? So we'll start by writing the percent change equation, which says that change equals a percent of the original value. Okay, the question says, what is the rate? So we're looking for the percentage. So we'll put R. And we know that the original price, right here, the original price was $95. The other thing that they tell us right here is that the ski jacket was discounted by $28.50. That means that the price is going to go down by $28.50, which means this number here is the amount of change. $28.50 is the amount of change. So there's your percent change equation. And now we have to get the value of R. R is on the right-hand side of the equal sign. It's being multiplied by 95. So we're going to have to divide by 95 on both sides. On the right, 95 divided by itself is 1, leaving us with R. 2850 divided by 95, well, that'll give you a decimal of 3/10. But remember, we need to convert this into a percentage. Move the decimal over once, twice to the right, and you are going to get 30%. So we can say that there is a 30% discount. In example 6, it says that a $45 ski jacket is now on sale for $36. What is the rate of discount? Okay, so this is similar to the question that we just answered. We're going to start with the percent change equation. Change equals a percent of the original price. Again, it says, what is the rate? R is what we're looking for. Originally, it was $45. We need to know the amount of change. Well, it was $45. Now it's on sale for $36. Okay, here we have to calculate the change. That's where it's different than this problem where they gave us the change. Here we have to calculate it. So the old price was 45, the new price is 36. If we subtract those, that gives us 9 for the amount of change. 9 equals R times 45. R is on the right side of the equal sign. It's being multiplied by 45, so we'll have to divide by 45 on both sides. 45 divided by 45 is 1, leaving us with R on the right. 9 divided by 45, punch that in, and you get 2/10. Convert it into a percent now, and we get 20%. So here we can say that there is a 20% discount. In the next part of our lesson, we're going to talk about percent error. Percent error is a ratio that compares the inaccuracy of an estimate, which is called the amount of error, to the actual amount. Okay, so we compare the amount of error to the actual amount, which is why our equation right here says that the amount of error equals a percentage of the actual amount. So this is the equation that we'll always use for percent error. Okay, finding the percent error is similar to finding the percent of change, but instead of finding the amount of increase or decrease, you're going to find the amount that an estimate is greater or less than the actual amount. So in our first example, question number 8, it says that suppose you guess there are 300 gumballs in this jar, but there are actually 400 gumballs. We're going to calculate the percent error in the guess that we made. So we'll start by writing the percent error question, which says that the amount of error is equal to a percentage of the actual amount. Okay? Well, it says to calculate the percent error. So we're looking for R, which is our rate, the percentage. And we guessed 300 gumballs, but there's actually 400 gumballs. So the actual amount was 400 gumballs. How much error did we have? Well, if there are 400 gumballs and we guessed 300, 400 minus 300, that means that we were off by 100 gumballs. So 100 is the amount of error. So this is similar to the percent change where you had to calculate the amount of change. Here you have to calculate the amount of error. 100 equals R times 400. R is on the right. It's being multiplied by 400. So we'll have to divide by 400 on the right, which means we do the same thing on the left. On the right, 400 divided by itself is 1, leaving us with R. Using your calculator, 100 divided by 400 is equal to 25 hundredths. But again, they wanted us to calculate the percent error, so we calculate this as a percentage, and that becomes 25%. So we would say that there is a 25% error in the guess. In example 9, it says that Lois measured a course for a cross-country race. The course should be 15,000 meters, but Lois accidentally measured the course to be 15,075 meters. What was the percent error in her measurement? So we'll go ahead and start by writing the equation. The amount of error is equal to a percentage of the actual amount. It says, what was the percent error? So we're calculating R. And then what we're going to do is plug in the values of the amount of error and the actual amount. To get the amount of error, we're going to take her measurement, 15,075, and subtract off what it should be, which is 15,000. And that gives us an error of 75 meters. So 75 is the amount of error. And it says the course is supposed to be 15,000 meters. That is the actual length of the course. So let's get the value of R. R is on the right. It's being multiplied by 15,000. So we'll divide by 15,000 on both sides. On the right, 15,000 divided by itself is 1, leaving us with R. Use your calculator. You'll punch in 75 divided by 15,000, and that's going to give you 5 thousandths, 0.005. Convert this now into a percentage. Remember, you move the decimal point once, twice to the right, which is going to be 5/10 of a percent, or 0.5%. So we will say that there is a 5/10% error in the measurement. In our next example, we're told that Jessie estimates the weight of her cat to be 10 pounds, but the actual weight of the cat is 13 7/75 pounds. Find the percent error in Jessie's estimate. So we'll start by writing our percent error equation. The amount of error is equal to a percent of the actual amount. Once again, we're finding the percent error, so R, the rate, is what we're looking for. Okay, the actual weight of the cat is 13 7/75 pounds, so that goes there. And we have to figure out how much error was there in the guess. So the cat actually weighs 13 7/75 pounds. Jessie estimated it to be 10 pounds, which means that she was off by 3 7/75 pounds. That goes in for the amount of error. So there's our equation. 3 7/75 equals R times 13 7/75. To get R alone, R is on the right side. It's being multiplied by 13 7/75. So we'll divide by 13 7/75 on both sides. On the right, 13 7/75 divided by itself is 1, leaving us with R. Use your calculator now. 3 7/75 divided by 13 7/75. And notice again, look at the numbers carefully on your calculator. You get a repeated decimal. Okay, 0 decimal. It goes 27, 27, 27, 27. So that's just going to be 27 hundredths repeated. Put the bar over the 2 and the 7. And now we need to convert this into a percentage. Okay, so remember, 27 hundredths repeated looks like that. Move the decimal once, twice to the right. So that's going to be 27 and 27, 27, 27, on and on forever. So this is 27 and 27 hundredths repeated percent. And so that's what we can write down. There is a 27 and 27 hundredths repeated percent error in her estimate. Okay, so for percent change, percent error, calculate the amount of change or error, and then you're always comparing that to the original or actual amount.